Okay, so as most of you know, on Friday, I realized that a lot of you needed a little bit extra help on these slides. So in some of your classes, we've already done some of the slides together. In some of your classes, we haven't done any of them together. I'm going to do slides 1 through 5 with you in this video. So watch the ones that you need, make sure you understand how it works, and then you should be able to finish the rest of the assignment. So let's start with slide 1. So first of all, we are being asked to find f of g of 0. But I can't find f of g of 0 until I first know what f of g of x is. So if I take f of g of x, that means I'm going to start with the f function, 3, but where I see an x, I'm going to use parentheses, minus 4. And then the g of x becomes the input. So let's do that in another color. So we start with f as the outline or framework, and then g of x becomes the new input. So where we left the input x blank, we're going to put everything that is g in its place. So negative 2x squared minus 1. Okay, now, since we know that's f of g of x, now I would take and plug in from this point your new input that's 0. So now if we want f of g of 0, we're going to copy everything, 3, negative 2, but where we see an x, we're going to use parentheses because we're going to change the input, and a 0. Okay, now, 0 squared is 0. 0 times negative 2 is 0. 0 minus 1 is negative 1. So we have 3 times negative 1 minus 4. 3 times negative 1 is negative 3. Minus 4 is 7. So this first answer is 7. Okay, now if we go to the next one, now they want us to kind of flip that around. Okay, so we want f of g, or g of f of 1. So we're going to start with g. So g of, our new input will be, we're going to use f of x first. So we're going to start writing everything that we know is g. So negative 2, leave a blank for your x squared minus 1. Now our new input is f, so we're going to put all of f into our parentheses, so 3x minus 4. At this point, now go ahead, now that we know what g of f is, now let's put our new input 1 in. So g of f of 1 is negative 2 times 3. Leave x as parentheses. Put a 1 in your new input. Okay, now let's simplify this. So we've got 3 times 1 is 3. Minus 4 is negative 1. So negative 2, negative 1 squared minus 1. Now from this, you're going to do the squared next. So negative 1 squared is positive 1. So negative 2 times 1 minus 1. That's negative 2 minus 1, negative 3. Okay? All right, now I marked these out so you don't have to do them. Moving on to slide number 2. Okay, so now slide number 2 gets a little bit different because they're bringing in this new letter H. Also, this notation threw some of you off on Friday. So in your notes on Thursday, I used this notation, but I used it very briefly and didn't focus on it a whole lot. This open circle here is not a multiplication symbol. This parentheses is not multiplication. What this is happening is this is saying the exact same thing as P of Q of X. It's just a different notation to represent the exact same problem. So what they want you to do is they want you to build this composite function, P of Q of X. But that's a whole lot to write every time you want to write it. So instead of writing that, they're going to say when you find that new function, we're just going to call it H. Okay, so that's where this H comes in. So first, let's figure out what H is, okay? So H is P of Q of X. So H of X is the same as P of Q of X. So we're going to start with P, X squared. So leave X as a large parentheses and then keep copying the rest, it's squared. Then we're going to put q inside x minus 5. So this is h of x. So if I want h of negative 3, I have negative 3 minus 5 squared. Negative 3 minus 5 is negative 8. Negative 8 squared is 64. Okay? Now the domain. In order to describe the domain of h, what I would do if I were you, if I would go to Desmos, I would type in h's equation. And look at the picture. Okay, now I am going to go to Desmos. Our equation is parentheses x minus 5 squared. So parentheses x minus 5 squared. Okay, so from here we can tell the domain, it's going to go forever left and right. So the domain of this is, we can say all real numbers. Or you could say negative infinity to positive infinity. There's lots of ways you could write that. The range, if you notice my y values, the lowest this graph goes is at 0, but then it goes up to infinity. So I'm going to say the range is from 0 with a bracket, because we can touch it, to infinity with parentheses. All right, slide number 3. First, I want us to find what we're calling g of x, which is p of q of x. So we're going to do p of q of x, and we're going to call it g. Just because p of q of x is a lot of things to write. So to find p of q of x, we are going to start with p. So we start with a large parentheses for x, and then plus 4. Q becomes my input, so absolute value of x. So p of q of x is the absolute value of x plus 4. Now, they want you to find a new one we're calling f, and it's q of p of x. So this function we're going to call f is really q of p of x. So we're going to start with q, so I have an absolute value, and then my x becomes the new input is p, so x plus 4. So it's absolute value, x plus 4. Are these inverses? No, because p of q of x and q of p of x simplified to more than just x. So remember from our notes last week, if we have two functions that are inverses of each other, then when I find their composite, when I put one of them inside of the other, it should simplify to just an x. But I have x and 4 in both of those, so they are not inverses of each other. Slide 4. Okay, so we've got a lot of things going on. So first of all, we're going to figure out which of these statements are true, and we're going to drag and drop check marks. I can't drag and drop because I'm not in Google Slides, so I'm just going to put a check mark. So first let's find f of g of x. So f of g of x, we're going to start with f, 2, leave x blank, minus 1. We're going to put g of x inside of it, x minus 1 over 2, and let's simplify. So we've got, this is really 2 over 1, so we have 2x minus 2 over 2, minus 1. That all simplifies to x minus 1 minus 1, so x minus 2. Okay, so f of g of x is x minus 2. Okay, then let's find g of f of x. So g of f of x, we're going to start with the function g, so leave a parentheses for x, minus 1 over 2. We're going to put f inside, so 2x minus 1. Now there's nothing to distribute, so I don't have to keep my parentheses, so we've got 2x minus 1, minus 1 all on top, 1 on the bottom. Oh, that's not right. Yeah, G had a 2 on the bottom, huh? Okay, so this is 2x minus 2 over 2, which is x minus 1. So those are not equal to each other. Okay, now we need f of h of x. All right, so let's erase this. All right, f of h of x, we're going to start with f as the outline, so 2 parentheses minus 1. We're going to put h as our new input. H is x plus 1 over 2. Okay, so this simplifies to x plus 1 minus 1, which is just x. And they want to know, is that the same of h of f of x? So h of f of x. Start with h, so parentheses for x, plus 1 over 2. Put f inside, so 2x minus 1. So I have 2x minus 1 plus 1 over 2. It's 2x over 2, which is also just x. So yes, these are the same, and they're also inverses. So we can say that f of x and h of x are inverses because when we did the composite functions, they both gave us just x. Okay, so now let's double check this last one. That's better. All right, so we've got f of j of x, so f of j. So I'm going to start with f, so 2, leave a space for x. Now put the function j inside, so 1/2 x plus 1/2. 2 times 1/2 is 1x. 2 times 1/2 is 1. So this all simplifies to just a single x. Okay, now we want j of f of x. So j, I should use lowercase, j of f of x. So start with j, so 1/2. Leave x plus 1/2. We're going to put f inside, so 2x minus 1. 1/2 times 2x is just x. Half of 1 is a half, so minus a half plus a half. So I'm left with just x again, so we can say that f of f and j are also inverses. So really what's happening, h and j are technically the same function, they're just written in 2 different ways. So we can say that those are all inverses. All right, slide 5, this last one I'm going to do with you. So determine the inverse of the given function. Remember inverses, if your original graph has x, y coordinates, then in order to find the inverse, you switch the x and y. Okay, so my new function will be the ordered pairs 8, 0. So I just switch the x and y. 7, 1. 6, 2. 5, 3. And 4, 4 is the same point. Okay? Is the inverse a function? In order to be a function, your x values are not allowed to repeat. So my x values, 8, 7, 6, 5, 4. No x values are used more than once, so we say yes. Each x value is only used one time. Okay, now I'm going to go further and ask you, is the original also a function? So, except the fact that they told you. We've got 0, 1, 2, 3, 4. So yes, the original is a function because the x values do not repeat, and the inverse is also a function. Okay, so that should give you a little bit more guidance and a little bit more help on how to do the rest of these slides. So finish the slides and then read the instructions on Canvas to know how to turn them in.